This is Math 2, Unit 6, Lesson 5. Again, that's Math 2, Unit 6, Lesson 5. Everyone should have their Unit 6 packet number 2 out. We did this together in class, or you guys started it in class. I'm going to have you flip over to Worksheet 5. Right now, if you can flip over to Worksheet 5. And what we're going to do today is homework notes. I'm going to do a few of these with you. And whatever I don't do, you complete on your own during class. And what you don't finish in class, you take home for homework. Okay, first one I'm going to do is number 1. It says here at the top, determine if the dilation is a reduction or enlargement. And we talked in class yesterday about enlargements and reductions. Enlargements happening when your scale factor is larger than 1, like 2, 3, 4, 5, or even 1.5. And the reduction, your scale factor is smaller than 1, 1/2, 1/3, 2/3, and your scale factor is never negative. Okay, so determine if the dilation is a reduction or enlargement of the figure using 0, 0 as a center of dilation. We did not use 0, 0 yesterday, but we are doing it today. Graph the image of the figure using the dilation given. Okay, so we should know enough to know that if the dilation is 2, is it going to be a reduction or an enlargement? It's bigger than 1, so it will be an enlargement. All right. First thing I'm going to do, only because it's the X and Y axis are really light, I'm just going to darken in at the origin just so I can tell when I'm counting my up and over, it's easy to see the X and Y axis. Okay, so scale factor of 2 with the center of dilation at 0. We did this already yesterday. You go up 1 over 1 to get to I. So we're going to do that a total of 2 times. Up 1 over 1, that's the first time. Up 1 over 1, that is the second time, and that is your I prime. Okay, going back to the center, at the center being at 0, 0, I go up 2 to get to B. So from 0, 0, I go up 2 to get to B, that's 1. I go up 2 more, that's 2. This is B prime. And then I go back to the origin to get from here to Q. I go up 2, left 1, which means I'm going to do that a total of 2 times. Up 2, left 1, that's the first time. Up 2, left 1, that's the second time, and this is Q prime. Back to the origin, I go down 1, left 1 to get to M. So I'm going to go back to the origin, down 1, left 1, that's the first time. Down 1, left 1, that's the second time. And that is M prime. You do not need a ruler for these. You can just connect. I am going to use a ruler, but again, you do not have to. All right, and there is our image with the scale factor, dilated with the scale factor of 2, and indeed you can see it did get larger. Okay, next one I'm going to do is number 2, and the scale factor, the dilation is the scale factor is 0.5. 0.5, remember, is a fraction of 1/2. Either way, 0.5 or 1/2, you can see that is smaller than 1. So will that be an enlargement or a reduction? Correct. It is a reduction. It's a reduction because 1/2 is smaller than 1. Okay. So one more time, I'm going to find the x-axis. It's here. Y-axis at the origin. I'm just going to mark it so it's easy to find. Now this one's going to be a little difficult. End up a reduction, it's going to end up smaller, and as it is, this triangle is already small. So I'm going to go, to get to Q, I go up 1, 2, and over 2. Cut both of those in half. That's up 1 over 1. Up 1 over 1. That puts me right there. That is Q prime. Okay, from back to the origin to get to U, I go down 1 over 2. Down 1 over 2. Now if I cut that in half, I can't go down a full 1. I have to go down a half and over 1. Now I know that I'm going to zoom in just a smidge. Okay, so what was done? From the origin to U, I went down 1 over 2. 1 cut in half is a half, 2 cut in half is 1. So I go down a half over 1, and that puts me at U prime. Okay, to get to H, it is left 1, so I'm going to go left a half. It's going to end up pretty messy because I already have my blue line there. But that there is my little triangle. You know, that looks wonky and ugly, but it's there. It's half the size, so it is smaller, and it's right there. Okay. Next one I'm going to do is number 3 with the dilation of 3 halves. Is 3 halves bigger than 1 or smaller than 1? 3 halves is 1.5. and that is bigger than 1. So what you're going to do is know that it is first, recognize that it is an enlargement. Okay, x-axis, y-axis, just to get an idea of where it's at. Okay, from here to G, I go up 1 over 2. Now, another thing you can do, and you can only do this trick when your center of dilation is at the origin. And I'll show you the trick now. G is 1, 2, comma 1. How did I get that? From the origin, I go over 2, up 1. P is from the origin, left 1, up 1, 2, 3, negative 1, 3. Again, that's from the origin, left 1, up 2, 3. I'm just finding the ordered pairs. And then find the ordered pair for B. Go ahead and do that now. Okay, from the origin, go left 1, 2, and down 1, 2. Okay, and what's nice about the center at the origin is you can simply multiply each ordered pair by your scale factor. Again, that's a shortcut. We could have used it on 1 and 2, but they were quite easy to graph on their own. This is easy to graph as well, but we're going to show you the shortcut now. P prime. Okay, so what you do is you multiply 2 times 1.5, and 2 times 1.5 is 3. And then you take 1 and you multiply 1 by the 1.5 because that's the scale factor, and 1 times 1.5 is simply 1.5. So what I'm doing is I'm taking my x and my y and multiplying each one by 1.5. Negative 1 times 1.5 is negative 1.5. 3 times 1.5 is 4.5. And then we're going to do it here as well. Negative 2 times 1.5 is negative 3. Negative 2 times 1.5 is negative 3. You can plug those in your calculator, do them in your head, by hand, totally up to you. Okay, so I'm going to plot that. 3 over 3 up 1.5. 1, 2, 3 up 1.5. That is my G prime. P prime is left 1/2. Sorry, where am I at? Left 1.5. Left 1.5 up 4.5. 1, 2, 3, 4.5. That is the after school bell. That is not for you. Okay, so I'm going to repeat the P. I went left from the origin, left 1.5, 1.5, and then up 1, 2, 3, 4.5. That's P prime. And my B prime is left 3, down 3. 1, 2, 3, 1, 2, 3. And that's it. You connect. Again, you're allowed to use that shortcut only when your center of dilation is at the origin. We wouldn't have been able to do this yesterday on yesterday's notes because those were not at, the center of dilation was not at the origin. And that there is your enlargement of 1.5. So it got 1.5 times bigger. Got it? All right. Next one we're going to do is number 5. Okay, so what this is asking us to do, it gives us an example here. It says write a rule to describe each dilation. One thing you can do is use the shortcut we did earlier, but kind of working backwards. For example, first find the origin. This is the x-axis. This is the y-axis. So find a point, like say N and N prime. Okay, so what is point N? Right 1 up 2. And N prime is right 1, 2, up 1, 2, 3, 4. And figure out what your scale factor is. And that's what they're asking us to do here. Figure out write a rule to describe each dilation. So what you can do is, remember we talked about in notes the new over old to describe our scale factor? Well, do that here. For the x variables, new is the n prime, old is the n, so 2 over 1 reduces to 2. For the y, 4 over 2 reduces to 2. So what's the rule? It's getting twice as big, because that's what the scale factor does, is it enlarges or reduces, and since it's 2, that means it's getting bigger, it's getting 2 times as big. So that's where the 2x and the 2y are coming from. So one more time, how did we find that? We first find, it doesn't matter which point you use, I just randomly picked N. You could have used T and T prime or L and L prime, it doesn't matter, pick one. N and N prime, I found each ordered pair. Then I did my scale factor rule for dilations, new over old. 2 over 1 is 2, 4 over 2 is 2, 2x, 2y. All right, so let's try it for this one. Find your x and y axis. There's the x-axis. There's the y-axis. Again, it doesn't matter. I'm going to pick U only because I don't want to pick a point that's on the x-axis or the y-axis, because I'm dealing with zeros and it's a little trickier because I don't want to have to be, I don't want to work with zeros pretty much. So I'm going to do U and U prime. U and U prime. All right, U is up 1, 2, 3, 4. And let's see, 1, 2, 3, 4, and left 1, 2, 3, 4. U prime. First, can you tell if it's getting bigger or smaller? U prime is the dilation, the dilated image. It is getting smaller. Okay, so U prime is up to, left to, and I'm sure you can tell already that it's how much it's shrinking by, but I'm still going to do the rule, new over old. For the x, that would be, new is the U prime, 2 over 4. And for the y, it's going to be negative 2 over negative 4. 2/4 reduces to 1/2. Negative 2 over negative 4 reduces to positive 1/2. Therefore, the scale factor is 1/2, which makes sense because 1/2 is smaller than 1, which means it's a reduction. And indeed, this image did get smaller from the original. So you would write it like this, x, y, the rule changes it to 1/2 x and 1/2 y. And that's what we did pretty much over here. We found our x and y's and then applied a rule like this, 2x and 2y. 2 times x, 2 times y, 2 times x, 2 times y. And we just kept doing that and then ended up, in this case it wasn't 2, it was 1.5. We multiplied x and y by 1.5, x and y by 1.5, x and y by 1.5, and got our new image. All right, that is it for the front page. We did about half of them, so the other half you're doing, actually more than half. You only have 2 on the front page to do alone. All right, let's flip it over to the back page. Six and 7 are the same as what we just did. So pick a point, like say D and D prime, and then do new over old for x, do new over old for y, and find your scale factor. And let's say the scale factor is 3, then you would write 3x, 3y. Okay. Numbers 8 through 12. Determine if the scale factor will reduce or enlarge the figure. Find the coordinates of the vertices of each figure after the given dilation. All right, we're going to use our shortcut for these since we don't have to graph. And we know enough now to know dilation of 2 means it's going to be an enlargement. It's going to enlarge. Why? Because 2 is bigger than 1. And the dilation is 2. Now, this whole worksheet is working with it being the center of dilation at the origin. The center of dilation at 0, 0. And only when the center of dilation is at 0, 0, we can use the shortcut where we just multiply. So let's do that. We take each value, x and y, x and y, x and y, x and y, and multiply them all by 2. And that's all you have to do here. Negative 2 times 2 is negative 4. Negative 1 times 2 is negative 2. Negative 2 times 2 is negative 4. 1 times 2 is 2. 2 times 2 is 4. 1 times 2 is 2. 2 times 2 is 4, and 0 times 2 is 0. And that's your new set for W prime, E prime, J prime, and X prime. We didn't have to graph this, but if you did, you'd end up with an original quadrilateral and then a second one that's twice as big. Okay, the next one I'm going to do is number 9. Dilation is 3/2. Is 3/2 bigger than 1 or smaller than 1? It is bigger. 3/2 is, remember, 1.5, which means it's going to enlarge. And it's going to enlarge 1.5 times. So take each one of these and multiply them by 1.5. So you take 2. Negative 2 times 1.5 is negative 3. Again, you can plug that in your calculator, do it in your head or by hand. 0 times 1.5 is going to stay 0. 1 times the 1.5 is 1.5. 2 times 1.5 is 3. 3 times 1.5 is 4.5. And negative 2 times 1.5 is negative 3. And that's it. And that's what you would do for each one of these. Here, with the dilation of 1/2, is that going to be an enlargement or a reduction? A reduction, right, because 1/2 is smaller than 1. And you take each one of these numbers and you multiply them by 1/2. If you want to plug it into your calculators, that's multiplying by 0.5. Excuse me. Again, you take each one of these and multiply each one by 0.5. Okay, next one I'm going to do is from the bottom section. I'm going to do number 13. Okay, so let's read what they're giving us. It says here, write a rule to describe each dilation. So I'm going to take a back step up here. What they're doing is they're giving us the original set and the new set. We have to figure out what the scale factor is. They're going to give us the original set and the new set, and we have to figure out what the scale factor is. So let's look at the example they gave us. Here's the original set, and here is the dilated, the new set. And then to find the scale factor, remember it's new over old. So pick a point just like we did on the page before. It doesn't matter which. I'm just going to use G and G prime. And remember, you do new over old, new being the prime. So for the X, it's going to be 0.5 divided by 2. How did I get that? 0.5 from the X value of the G prime and 2 from the X value of the G. New over old. And when you plug it in your calculator, 0.5 divided by 2, you end up with 0.25. What's 0.25 as a fraction? That is 1/4. So X's scale factor is 1/4, and indeed they have that there, 1/4 X. Okay, how about the Y? We do new over old, so that's -1 over -4. The negatives reduce, and I end up with 1/4, and indeed that's what they have there, 1/4 Y. Okay, so let's try 13. Remember, new over old, do X, and then we'll do Y. And it doesn't matter which point you use. I'm not going to use anything that has a 0, so I'm going to use this one right here. So I do 0.25 because that's new, and it's negative. Negative 0.25 divided by -4. And when you divide 0.25 divided by 4, and I apologize, and I'm sure you guys are like, what the heck is she doing? I crossed them, and it's only because I was looking straight up, but X matches with X and Y matches with Y. My apologies, and I'm hoping you guys caught it and fixed it on your own. Okay, so negative 0.25 divided by -1. The negatives cancel out, and 0.25 divided by 1 is 0.25, which we've talked earlier already is 1/4. So it's going to be X2 1/4 X. Let's check the Y now. Y is 1 divided by 4, which reduces to 1/4. Therefore, the scale factor for Y is 1/4 Y. So the rule is 1/4 X, comma 1/4 Y. All right, the rest of the class time you are working on this worksheet, making sure you get it done and helping each other if needed.